Good day again to everyone. Before I'm going to start my discussion for this lesson, now may I again encourage everyone to please support this channel by clicking the subscribe button, sharing this video to your classmate and to your friends who are watching, who are also taking the basic calculus as subject, and of course by clicking the notification bell so that should there be any future lesson that will be posted, you will be notified. Okay, so again, our focus today is of course the basic differentiation rules. Okay, meaning to say these are rules that will be used in differentiating the limit or getting the derivative of the function. Okay, so there are rules, and these rules will shortcut your computation of the derivatives, unlike the previous lessons that it is so tasking, very long. Our method of deriving the derivative is a very long one. Okay, but that is how to learn the derivatives. Okay, now we have in here number one rule in differentiating the function is the constant rule. If we have a constant rule in the limit, we do also have constant rule in the derivatives. Now what is the meaning of this one? Meaning to say, if you have a function that is considered to be a constant, the derivative, okay, the derivative of a constant function of a constant function is always zero. Okay, zero. So that is the derivative of a constant function or a constant. Definitely when we are going to have the notation of this one, this can be written as d over dx of c, which is the same as 0. Now mind you, the c must be a real, okay, must be a real number. Okay, so the c must be a real number so that we can derive the constant. Now you might be asking, what is the meaning of d over dx? The meaning of d over dx symbolize operation, or this is considered to be an operator. Okay, operator. So meaning, if you seen this notation, it means that you are actually taking the derivative of a function. Mind you that in the previous lesson, I already presented this one, that your slope, which is the same as the limit, as your change of x is approaching 0 of f of x plus change of x minus f of x over change of x is also what? Is also a derivative. This is the same as y prime. This is also the same as, because that is a function, that can also be a f prime of x. Now, these are the notation of the derivative. This can also be what? D over dx. Okay, so that is the meaning of the d over dx. It pertains to the derivative. Okay, so just to recall, we have in here the notation of the derivative. Okay, so meaning the m is the same as y prime, the same as f prime of x is the same as d over dx. It pertains to only one concept. They are pertaining to what? Derivatives. Okay, okay, again, I'm sorry, this must be derivative. Okay, derivative. Okay, or derivatives. Ayan. Okay, now what is meant by constant rule? Let's go back. Now, to illustrate this one, let's try to give an example. Okay, an example is we have in here. What about if we have f of x is equal to 7? Okay. Now, what would be its derivative? So, to get the derivative of this one, that can be written as d over dx of what? Of 7. Okay, of 7. Now, what would be the result? That is 0. Or that can be written as what? D over dx of f of x is equal to 0. Why 0? By substitution. The f of x, okay, the f of x is equated to what? 7. By substitution, we can write this one as d over dx of 7 is the same as 0. So that is the meaning of the derivative. Now another one in here is, what about if we have in here y is equal to 0? What would be its derivative? Now to get the derivative of that one, that can be written as what? D over dx. Okay, d over dx of what? Of 0. Okay, and so what is the derivative? That is the same as 0. Okay, this can also be written as what? Or, shall we say or? This can be written as what? The derivative is derivative d over dx can also be written as what? Y prime. Okay, y prime. So, if you send the word y prime, that is the same as what is the derivative of the y is equal to 0. That is the same as 0. Okay, so that is the same as 0. Now, what about if we have this one? Okay, another one is, let's try to have, okay, let me to do this one. But I will not, okay, so we have in here, so shall we say this is number 1 or letter A? Okay, letter B. What about if we have letter C? So our letter C can be written as y is equal to k pi squared. What is the derivative? Now remember, before we're going to get the derivative, we have to define what is k. So if k is constant, then y prime or the derivative is still 0. Okay, still 0. So that is the rule number 1, the constant rule. What about the next? We have in here the number 2, the power rule. Now what is the meaning? So before we're going to illustrate this one, now if n is a rational, okay, rational number, then the function Then the function f of x, which is equal to x raised to n, is differentiable. Differentiable. Okay, and if that is differentiable, then what is the notation? The notation can be written as what? That can be written as d over dx of x raised to n is the same as n x raised to n minus 1. Okay, so that is the derivative of a given function. Okay, now if the function to be differentiable at x, which is equal to 0, n must be a number such that x raised to n minus 1 is defined on an interval containing 0. Okay, so that is the meaning. Now, how do we apply this one? So to understand this rule, now may we take a look. Okay, may we take a look on some of the application. So we have in here, okay, we have a function, example, okay, we have a function, shall we say letter A, f of x is defined to be x raised to 3. Okay, now what must be its derivative? So notice that your n in here, okay, our n is what? That is the same as 3. Okay, so the n is 3. Now applying this pattern or applying this power rule, now to get the derivative, we can have now the d over dx can be written as x raised to n is the same as 3x raised to 3 minus 1. Okay, so we can have now the result d over dx of x raised to n is what? Notice that is the same as 3x raised to 2. Notice that whatever my exponent in here, the exponent will always be the numerical coefficient, okay, of x. But in here you have to deduct 1. When you use this one to the numerical coefficient of x, you have to deduct 1 in the exponent. So this must be the result. Or, okay, or this can be written as what? This can be f prime of x is equal to 3x raised to 2. Okay, so again, the derivative of the given function f of x, which is equal to x raised to 3, is the same as 3x over raised to 2, or that can be written as f prime of x is equal to x raised to 2. Okay, letter B. What about in here? We have in here letter B. Okay, in our letter B, we have g of x. let's say we have g of x is equal to the cube root, okay, the cube root of x. Now, how do we get the derivative of this one? Now, to get the derivative of this one, of this cubic number, now convert it into exponential form. So the exponential form of this one is the same as g of x is the same as x raised to 1, x raised to 1/3, okay, 1/3. So that is the exponential form. Now, after converting them to its exponential form, that's the time we can get now the derivative. And so what is the derivative? That is saying g prime of x is the same as 1/3 x raised to 1/3 minus 1. Now, what would be now the result? The result would be g prime of x is the same as 1/3 of x raised to negative 2/3. That is the same as 1/3 minus 1 is the same as negative 2/3. So that would be the result, okay? So that would be the result. Now, notice that we need to, if we would like that our exponential form will be converted into a positive number, this can be what? This can be converted into a positive number by how? By putting the numerator into the denominator by having now a result of g prime of x, okay? So bring down this one, okay? So we have now in here, that is the same as 3, okay? 3x raised to 2/3. So that must be the derivative. Another one example is we have in here, okay, let's say letter C, okay, letter C. We have in here y is equal to 1/x raised to 2, okay. Now, how are we going to get the derivative of this one? Again, when we are going to get the derivative of this one, see to it that our rational number will be converted into a whole number. And so how is that? There will be a movement. So how do we move that one? Notice that when we are going to convert this one into a whole number, this can be written as what? Y is equal to x, okay, raised to negative 2, raised to negative 2. And so notice now that we have in here now the form of our equation, y is equal to x raised to negative 2. We are now ready to get the derivative, okay? So how is the derivative of this one? Now again, we say y prime, okay, is equal to, bring down this one as your numerical coefficient. We have now negative 2x, and that is negative 2 minus 1, okay? Now, what is the final answer? Our final answer now would be negative 2x raised to negative 3. Or, if you want that you will have a positive exponent, you can have this one to be your result. Y prime, bring down the numerical literal coefficient with an exponent of negative 3, and so it will give you now negative 2 over x, and that your exponent will become now positive, okay? So that would be the result. Y prime is equal to negative 2 over x raised to 3. Okay, so that is how to make use of the power rule. Okay, so a very easy one. So power rule. So again, now what about if we consider another one? Shall we say we have in here, okay, letter D. Letter D. Our function is f of x is equal to x raised to 4. Okay, what would be its derivative? Okay, we say that the derivative of this one is f prime of x. Again, bring down as the numerical coefficient, so we have 4x, and so minus 1 as your exponent, so it will give you 3. So that is the derivative of the given function. Now, you might be noticing what is the derivative we are talking in here. Again, the derivative is actually the slope of a given tangent line to a certain point on the curve. Okay, so notice that if we are going to have the slope of the tangent line having our function to be x raised to 3, now the slope must be, what is that? 3x raised to 2. So that if we consider a point, should there be a point given, now we just multiply that x raised to 2, and so that would be the accurate slope of that tangent line to a cubic function to that certain point called point of tangency. Okay, point of tangency. Another rule is what we will now the constant multiple rule. Constant multiple rule. Now, what do we mean by this? If the function is a differentiable function and C is a real number. C is a real number, then CF is also differentiable. Okay, differentiable and can be written as what? D over dx of C f of x. C f of x, okay, is the same as C f prime of x. So that is the meaning of constant multiple rule, and that is the notation is we have in here. Okay, so what is the notation? The notation is d over dx of cf of x is equal to c prime of c f prime of x. Okay, so how do we apply this one? Okay, how do we apply this one? So assume that we have in here number 1, letter A example. Okay, letter A example, we have in here y is equal to 5x. Okay, yan, 5x raised to 3. Now how are we going to apply? Okay, how are we going to apply this one? Now notice that when we are going to apply, we have in here now y prime can be what? 3. And 3 multiplied by 5x raised to 3 minus 1. Okay, so what would be the final answer? The final answer would be 15. Okay, 15x raised to 2. That would be the final answer or the derivative. Okay, so the derivative of y is equal to 5x raised to 3 is the same as y prime is equal to 15x raised to 2. Okay, so now you notice that we only make use of a single term. What about if we consider this one? Okay, what about if we consider again this one, letter B? In our letter B, we have in here f of x. Okay, f of x is equal to 2 over x. Yan, 2 over x. And so how do we do this one? Again, to do the problem, convert it in such a way that you will not be having a rational function. So convert it in such a way that this must be a whole number. And so how is that? Notice that your x is the denominator and has an exponent of 1. So that if we're going to get the derivative, I will first convert it. So by saying f of x, okay, is equal to 2 and 2. I will raise that up to the numerator. So I have in here x raised to negative 1. Having said this one, converted form of the function, f of x is equal to 2 over x. Now, it is the same as f of x is equal to 2x raised to negative 1. Now, having said this one, we can now get the derivative by applying the constant multiple rule. Now, how is that? We say that your f prime of x, okay, f prime of x is equal to negative 1. Bring it down again as your multiplier, that is your n. Negative 1 multiplied by 2x raised to negative 1, the original, minus 1. Okay, so what would be the result? The result would be f prime of x is the same as negative 2x raised to negative 2. Okay, raised to negative 2. So that again, what about if you do not like to see a negative exponent? You can again convert this one by bringing it down to the to the denominator, the x raised to negative 2. By having now a new statement saying f prime of x is the same as negative 2 over x raised to 2. That would be the derivative. Okay, derivative of our function f of x is equal to 2 over x. Okay, 2 over x. Now, another one is, what about if we consider this one? Okay, what about if we consider this problem? Okay, our problem is, shall we say, letter C. We have in here f of t, and f of t is equal to 4t raised to 2 over 5. So how do we do this one? Okay, how do we do the problem? Now, to do the problem, notice, okay, notice that when we are going to have this one, we can have f prime of t. This one, we will bring it down. Okay, we'll bring it down. That is the same as 2 multiplied by 4t raised to 2 minus 1. Of course, over 5. Okay, over 5. Now, what would be now the answer? The answer would be, we have f prime of t will be 8. 8t over 5. Okay, 8t over 5. And so that must be our derivative. So the derivative is f prime of t is equal to 8t over 5. Okay, over 5. Another one is, what about if we would like to do this one? Okay, shall we say we have in here letter D. In our letter D, we have y. Y is equal to 2 times the square root of x. Okay, so how do we get the derivative? Again, to do this one, like the rational number, we converted this one to a whole number, and that must be the same as in here. So that if we have a radical number, we convert this one into its exponential form. So what would be the exponential form of this one? Okay, that can be written as y is equal to 2 x raised to 1/2. Okay, from that's the time we're going now to get its derivative. So what would be its derivative? We say that y prime is the same as 1/2, which is the exponent, okay, multiplied by the original 2, and of course x, that x raised to 1/2 minus 1. And so what would be the answer? Let's try to have y prime is the same as 1 multiplied by 2. That is the same as 2 over 2 x raised to negative 1/2. Okay, or the result would be y prime is the same as 2 divided by 2, that is 1 multiplied by x, so it will give you x raised to negative 1/2. Now, having said this one, we have to put it back to its positive form, so our result would be y prime is the same as 1 over x raised to 1/2, or this can be written as y prime is the same as 1 over the square root of x. 1 over the square root of x. So that can be the possible answer. Okay, that can be the possible answer. The next problem will be letter E. Okay, so we have in here letter E. So what about if we have in here y is equated to, shall we say, 1. Okay, 1 over 2 the cube root of x raised to 2. Okay, so our next problem is y is equal to 1 over 2 the cube root of x raised to 2. Okay, so to do that one, now we will convert again this radical number into an exponential number, and then after that one, raise it to the numerator. This variable x will be raised to the numerator. So we will be making use of another paper. Okay, we'll be making use of another paper. Okay, so we have this problem. So we say that we have to convert this one into its exponential form. So we have y is equal to what? 1 over 2. What is the exponential form? This is the same as x raised to 2 raised to, what is that? 1/3. Okay, 1/3. So that is the exponential form. Now after that one, we say y is equal to, again, consider multiplying the power, their exponent, 1 over 2 x raised to 2 multiplied by 1, we have 2 over 3. So that this variable x with an exponent of 2/3 will be raised to the numerator. So it will be transformed into this form. Y is equal to x raised to negative 2 over 3 over 2. Now with that, that's the time we're going to get now its derivative. And so to get the derivative, we say that y prime, okay, y prime, what is our original base? We have in here x over 2, but we have in here the exponent, so our exponent is negative 2 over 3. Of course, we have the exponent negative 2 over 3. We always have the minus 1. Okay? So that we have in here now the next statement, y prime divided 1, that is negative 1. So, negative 1 over 3x. Now, how about that one? That is negative 2 over 3 minus 1. That is the same as negative 5 over 3. Okay? Now, we have now that one as the derivative. Okay? So, we have in here this one as its derivative. But we have to see to it that this must be positive. So, we can have now y prime over negative 1/3, negative 1/3 x raised to 5 over 3. Raised to 5 over 3. Okay? Or that can be written as y prime is the same as, we have in here negative 1 over 3, the cube root of x raised to 5. So this would be the final answer, final or derivative. So that would be the derivative of the problem. Okay, I hope you understand the concept of constant multiple rule. Okay, the concept of constant multiple rule. Okay, another rule in here is we have what we call now the sum and difference rule. Now, what is the notation of this derivative? The notation of this one is the same as this notation. D over dx of f of x plus g of x, okay, plus g of x is equal to their individual derivative. So it is equal to their individual derivative. And so what is the derivative of f of x? That is the same as f prime of x plus g prime of x. Okay, so that is the meaning. So that is for the sum. Okay, that is for the sum. Now what about for the difference? For the difference, it is the same. The notation is d over dx of the difference of f of x minus g of x. Now, what is their derivative? Or yes, what is the derivative? Of course, the derivative is equal to the difference of their individual derivative. So that is the same as saying f prime of x minus g prime of x. So that is their derivative. Okay, so that is their derivative. And so what about if we are going to consider, okay, consider the problem, okay, Our problem in here is we have in here letter A. Shall we say letter A? Our function, okay, our function is f of x is equal to x raised to 3 minus 4x plus 5. So this is the function that we have. Now to get the derivative, in here we get the derivative of individual terms. Okay, we will get the derivative of individual terms. And so the sum of x cubed minus 4x, I repeat, what is the derivative of the function f of x is equal to x cubed minus 4x plus 5. Now notice that it is composed of 3 terms. So to get the derivative, we will get the individual derivative of the number, okay, or individual derivative of the terms. Okay, so we have in here f prime of x is the same as, what are we going to do with this one? Bring it down, so as multiplier 3x, and so that is the same as 3 minus 1. And what about in here? That is actually minus 4, okay, minus 4, of course, x 1 minus 1, and of course this is plus 0, okay, so derivative of the constant is 0. So notice that f prime of x is the same as 3x raised to 2. Now what about this one? That is 4 multiplied by x raised to 0. Now we have said that any number that is raised to 0 will always be 1. So that is 1. And so final answer would be f prime of x. It will give you 3x raised to 2 minus 4. Okay, so that is how to do it. Now another one, letter B. Shall we say we have in here letter B. So we have g of x. Is equal to, that is equal to negative x raised to 4 over 2 plus 3x raised to 3 minus 2x. So how do we do the problem? Very easy one. So notice that when we are going to do it, we have now that is the same as g prime of x. Bring this down as multiplier. So we have in here 4 multiplied by negative x over 2. Okay, over 2. And of course, this is the same as 4 minus 3 plus this one, 3 multiplied by 3 x raised to 3 minus 1. And so minus 2 raised to 1 minus 1. And so you will notice that when we are going to have this one, this is multiply. Okay, this is actually multiply. So notice that 4 divided by 2 is the same as 2 2 multiplied by negative is the same as negative 2x raised to 3. I'm sorry, this must be 1. This must be 1. Okay? Plus 9x raised to 2 minus 2 x raised to 0. And so the result would be g prime of x is equal to negative 2x raised to 3 plus 9x raised to 2. Any number raised to 0 is 1 multiplied by negative 2 is negative 2. So these are the derivative or the slope of a given curve. Ayan. They're actually the derivative of the given curve. Okay? So that is how to get the derivative. So I hope with the 4 rules that we illustrated, you understand and you know how to apply these rules on getting the derivative of the given function. Thank you and more power.